Okay, so let's take a look at this guy, kind of the same concept, but now we're looking for a percentile. So what temperature represents the 90th percentile? And so let's kind of draw our picture to make sure we understand to start off. Let's lay out our information too. So we know that our mean is equal to 98.6. We know that our standard deviation is 0.73. Our first thing we want to do is we need to find our z-score, because what that z-score is going to allow us to do is eventually find our x value that represents that cutoff at the 90 percentile. So remember visually what's going on here is that we have a normal distribution curve. On this normal distribution curve, what we're saying is that we have essentially the 90 percentile. So we need to find this x value right there that represents this 0.90 or 90th percentile. So that's the area under the curve to the left. So we go to our table E, or standard normal distribution table. We're looking for 0.9. So remember, on the negative side, we won't get any larger than 0.5. So we need to go ahead and turn over to the other side and see that on this side we can start seeing in our 0.9 areas. Alright, so let me grab, I've got the wrong software pulled up there. Let me do that. Some remnants from last time. So we're looking for 0.9, and so we come across here. So let's see, there's 0.90320, 9490. So go up here across the top, and there we go. So 0.9 is going to be somewhere between that guy and that guy. So once again, we're placed with this situation of pulling our calculator out and saying, okay, if I did 0.9 minus 0.89973, that's going to be my difference. So remember, translate that into English for us, and that's going to be 2.7 times 10 to the negative 4, which essentially means that I have 2.7. I go 1, 2, 3, 4. Fill those up with zeros. Then my second one will be 0.90147 minus 0.9, and we get 0.0147, which in this point here shows us that that guy is actually closer. So believe it or not, he is only, if you think about that, subtracting down from 100, you're only 14 away from where we need to be. So we're going to use, we're only 0.027 away. So we're going to use this guy as our landmark, our probability to represent 0.9. So we come across the table. We got our 1.2. We're going to come up the table. So z is going to be equal to 1.2, and then we're going to go up to find that other piece, and 1.208. So 1.208, put that together, it gives us 1.28. Alright, let's head on back into our problem here. So in our problem, we come back across, and that means that our z-score is 1.28. We take that, and we're going to utilize that to find our x value now. So instead of using software or something to find an inverse norm or to calculate, we're going to look for that x value. So we know our formula is x is equal to our z times our standard deviation plus our mean. So x is equal to our 1.28 times our standard deviation of 0.73 plus our mean, which is 98.6. Pull out our calculator, and we have 1.28 times 0.73 plus 98.6, and we come out with an x value equal to 99.5344. And then at this point, we should determine what kind of rounding they want us to do. I don't see a particular rounding there. Let me go look behind the scenes real quick. I'll be right back. Alright, so we'll just go ahead and round that to 2 decimal places, because that's where the rounding rule is one more decimal place than the data we are given. So we have a mean of 98.6. So that means we'll go one more decimal place. So this would be x is approximately equal to 99.53. Alright, so play around with that. This is when you know a fixed percentile.